Have you ever really stopped to think about what's going on inside your phone or your laptop? I mean, really think about it. It seems super complex, right? Well, behind all those shiny screens and apps, there's a simple, universal logic that powers every single computer on the planet. And today, we're going to pull back that curtain.
So let me just start with a kind of wild thought. What if I told you that a massive supercomputer predicting the weather and that little fitness tracker on your wrist actually follow the exact same set of rules? It sounds a little nuts, but it's absolutely true. And by the end of this, you're going to see exactly what I mean. All right, so first things first. Why do we even have computers? What is their most fundamental job? Well, it all boils down to one single crucial transformation: turning useless stuff called data into valuable stuff called information.
Let's talk about data. On its own, data is just raw, unorganized junk. Think of a random list of numbers or words without any context. It's meaningless, right? It doesn't help you do anything. But that's where the computer works its magic. When it takes that raw data and processes it, it becomes information. All of a sudden, it has meaning. It's useful. It's something you can actually understand and make a decision with. And here is the perfect example. Look on the left. Data, 36, 41, 29. I mean, what is that? Who knows? It's totally useless. But after a computer does its thing, it becomes information. Average temperature, 35.3. Ah, now we know something. That little transformation is the entire point of a computer. So how do computers pull off this little magic trick? Well, they use two essential tools that have to work together perfectly: hardware and software. Okay, so first you've got your hardware. This is all the physical stuff you can actually see and touch. The screen, the keyboard, the mouse, all those little chips and wires inside. It's the body of the computer, basically. But, a body's not much good without a mind to tell it what to do. And that's where software comes in. Software is the set of instructions, the programs, the apps that tell the hardware how to act. Without software, all that fancy hardware is just a really expensive paperweight. Here's a great way to think about it. A piano is the hardware, right? It's this beautiful, complex physical machine, but by itself, it just sits there silently. The sheet music? That's the software. It has the instructions that tell the piano what notes to play to create a beautiful song. You need both. You can't have one without the other. Okay, so we've got the why, turning data into information, and we've got the what, the hardware and software. Now let's get to the how. This is the universal four-step recipe that every single computer follows to get its job done. It's called the information processing cycle. This right here, this is the blueprint for literally all of computing. I don't care if it's a giant server or your smartwatch, it follows these four steps in this exact order: input, processing, storage, and output. Let's break them down real quick. First up, we've got input. This is simply how we get data into the computer. Every time you tap on your screen, type on a keyboard, click a mouse, or even talk to Siri, you're doing input. You're feeding the machine the raw materials it needs to work with. Next, we get to the real magic: processing. This is where the computer's brain, the CPU, gets to work. It grabs all that raw data from the input and it starts crunching the numbers, running calculations, and transforming it from meaningless facts into useful information. This is the heart of the whole operation. So while the computer is in the middle of all this thinking, and even after it's done, it's got to have a place to put things, right? That's where storage comes in. The computer needs a spot to hold on to the data it's working on and the finished information it just created. And there are basically two kinds of storage you need to know about. There's primary storage, which you probably know as RAM or memory. Think of this like your brain's short-term memory. It's super fast, and it holds whatever you're actively working on right now. Then you have secondary storage, like a hard drive. That's the long-term memory. It's where you save your files, so they're still there after you turn the computer off. And finally, we get the payoff. Step 4 is output. This is how the computer shows you the results of all its hard work. It's the picture you see on your monitor, the music you hear from your speakers, or the paper that comes out of your printer. It's the final, useful product of the entire cycle. So yeah, those 4 steps: input, processing, storage, output, that's the timeless core of how any computer works. But in today's world, there's really a 5th operation that's just as crucial: communications. This is how computers talk to each other, sending and receiving data and linking all of their individual cycles together to create things like, well, the internet.
So now that we've got a handle on the timeless process that makes every computer tick, let's just take a super quick peek at where this whole thing is going. Honestly, if you want to know the future of tech, you just need to remember three simple words: smaller, faster, cheaper. That's been the name of the game for decades now. We are always finding new ways to cram more power into smaller spaces, make them work faster, and do it all for less money. This relentless trend is exactly why you have the power of a 90s era supercomputer sitting right in your pocket. So there you have it. That's the fundamental logic behind every single computer. But let me leave you with this question. Now that you know the cycle, input, processing, storage, output, can you see it happening on the device you're using to watch this right now? Because I guarantee you that entire universal process is happening right this second, probably in the palm of your hand. Pretty cool when you think about it.